Welcome to George and Jane YouTube video channel of adventures and hobbies. Please subscribe and like, comments welcome. Don't forget to browse the playlists.
Hi YouTubers, I'm in the garage. Got the fan here cooling my solar node down because it was over 60 degrees and I didn't want to charge it fully with the amount of heat that was in it. I'm actually charging it not by solar, obviously, because it's indoors. But anyway, that's not what I'm here to talk about. Is the four-way remote aerial switch unit I'm building based on a Practical Wireless magazine article, and all the coils now are wound, and they measure the correct resistance, or within between 27 and 31 ohms each. That depends on which multimeter I use, because I haven't got a very good multimeter. The main board here, circuit board, this has got the series dropper resistors in, and it's just like where all the wires come into and go out of, including the LEDs. There's the LED wire in here. I might actually wire it directly to the coil rather than run it to the board. It just makes sense to do it that way, because the negative of each winding is common, so I can jump them like that and then run the LEDs, and then I don't have to run these wires to the board and back out again. I can just do it like that. That's providing it's not going to pick up any of the radio frequencies coming down here. I'm thinking of having between the reeds here some coax, and you know, to the reeds, so it gives it a bit of screening. And the other thing I can do, if I want to, is get some copper clapboard and actually put a screen in between each of these and solder it like that to give a bit of separation, or even like that if I wanted, if I've got enough copper clapboard. But I won't decide that until I've got the reeds and see what it looks like. But I'm thinking of using screen cable, and that's as much as I can do today, because I'm still waiting on parts. I don't know whether it's because America's messing up everything, but there seems to be a big delay on getting things from China. I decided to put some screens in between the coils, basically because I had them, these offcuts of copper clapboard, and I've made up a small coax, this miniature coax, which is going to go on there, centre there, and each one of these will feed the reeds. So this end will be screened, the leads, as much as I can, and then the other end, it's only a short distance, so I'm hoping that'll be alright. This is I think it's RG213, very small cable coax, and I'm hoping I can use that in there for these at the front. It's held together with a grommet at the moment, but I'm hoping they'll go on there and it will split out. I'll stretch the wires out and show you what I mean. Okay, this is the small thin coax, so that'll go on the centre of that conductor like that. Hopefully you can see that, is that like that. And it might input the impedance, because they're all like 50 ohm coax, I'm not sure if it will upset it or not. I'd have to do some tests when I've got all the rest of the bits, compared to having just ordinary wires which are not coax, because 50 and 51 are all in sort of parallel. I don't know what the effect will be on a Nano V&A. Yeah, not sure. We'll see. It's made up anyway, we can try it. I'll give a test on this piece of wiring I'm planning on using, and this is what I'm going to use: some screen cable to go from the SO239 to this cable, and they're all in parallel and they're all screen cables. So what I've done, I've put a 51 ohm resistor on this end, on just one of them, just to check the SWR. And you can't see the screen, let me just put this off. And this is SWR readings. Just move this. Right. That's strange. That's better. At 5 meg, the SWR is 1.1. And as I move up, there are two bands I'm interested in. For the 40 meter band, it's 1.12 SWR into a 50 ohm load, 51 ohm load, and then as we go up the bands, 14 meg, say 14 and a half, it's 1.168, and then SWR increases as I get 26 meg. Let's go up to 30 meg, it's 1.3 to 1. That's with a 51 ohm resistor. I'll do some more tests when I've stripped the coax back here, and yeah, that's on that resistor, so I suppose I should unsolder it and put that one on there. So let's put the resistor on that end. If I hold it on to the case, yeah, it goes up to 1.75, but mind you, yeah, that's interesting. When I put my finger under another resistor, it goes down, the SWR at the high frequency end. Right, I'm going to disconnect that one and put that one on and see if it makes any difference. That's gone up slightly. It's just 1.3 to 1 at 30 meg with that resistor, just one resistor. Put the marker down. To go to 14 meg, 14.5, 1.1 and 7 meg. It's 1.1. They're the bands I'm interested in. Right, now what I can do now, I can get some wire and put some 4 strands of wire on the end to do this test and see what happens. Well, that's very interesting. Same sort of test. Turn the light off. So just bunch of wires, and this 1.1 at 7.5, 14 and a half megs, 1.2 and coming up to 30, 1.4. So this bunch of wires has a higher SWR than coaxial wires in parallel. Right, very interesting. So I shall probably will go with this then. But until I get all the rest of the equipment and bits arrive, I can't do a better test than that. But yeah, that's looking pretty good to me. Yeah.